Welcome back to Math 155, Section 8.2, Displaying Data. So in this lecture video, I'm going to show you what we so-called the quantitative type of data. Okay, quantitative. So the word quantitative simply means now my axis, my x-axis, I'm begin to use numerical value. The number one most important statistical graph is what we so-called the histogram. Histogram is basically like a bar graph, okay, of a frequency distribution. Okay, the horizontal axis is actually a number line. Okay, so what we notice about histogram is it's like a bar graph, but none of the bar is being separated. All the bars are actually connected. Okay, and there's a reason for that as well, to do that. All right, frequency polygon, okay, is actually a visual display of the frequency of each class of the quantitative data. Uses straight line to connect the points, okay, plotted above the class midpoint. So I will explain this class midpoint here just in a minute. All right, we have something called OGIF. We got stem and leaf plot, dot plot, and we also have just a regular line graph, okay? So frequency polygon OGIF is different than compared to what was so-called a line graph. All right, so let's take a look. This example, okay, this is a line graph. This is a regular line graph. So as you can see, the horizontal axis or the x-axis is using numerical value. So that's considered as a quantitative data. So the following line graph shows the price of the stock over the previous 2 weeks. Use the graph to determine the number of days in which the price was between $50 to $60. So between $50 to $60. Okay, number of days. So day 2 is 1. So that's 1, 2, 3, 4 days. Okay, so there are 4 days. Okay, there are 4 days that 1, 2, 3, 4 are the price of between $50 to $60. Okay, all right, that's all it is. Now, before I do the following example, I want to kind of mention these words. So a lot of these definition here got something to do with that histogram that I just showed you. So start out with the word distribution. Distribution is a way to describe the structure of a particular data set or population. Okay, we use the word distribution. So adding the word frequency in front of it simply implies that a frequency distribution, okay, is a table of value that occur in the data set and how often each value or range of the value occurs. So if I will scroll down here, okay, so this is called the frequency distribution. Now here my x-axis I'm using later grades. Okay, so remember now later grades can be translated into numerical values. So this is quantitative type of data. All right. Oh, so if I would say, let's just kind of mention this real quick. If I pretend to say A is ranging from 89, A is ranging from 89.5 to 100. So that will be, this will be a class. Okay, this will be considered as a class. So the grade or the x-axis, when we divide them out into each category, we call them the class. All right, so that's what this word, a class is a category of data in a frequency distribution. All right, so frequency is the number of data value in a category occurs. All right, so let's just count them, okay? Let's count them. So this is a frequency distribution. Let's count how many A's we have. So the number of frequency, 1, 2, 3, 4, 5. That's 5 of them. All right. Make sure we don't count them wrong, okay? B, the grade B, 1, 2, 3, 4. All right, so that's 4 times. All right, let's see how many times C occurs. 1, 2, 3. Well, that's just 3 times. All right, D, 1, 2, 3, 4, 5, 6, 7. All right, F's 1, Okay, so F occurred 2 times. All right, so that's how you do a tally or do a frequency. Okay. All right, class width. Class width is referring to the difference between the lower limits or the upper limits of 2 consecutive classes. So what is so-called the lower class limit is the smallest number of a particular class. So let me kind of go to this page real quick, okay? So so here you're looking at 1, 2, 3, 4, 5 different classes, okay? Lower class limit is the smallest value. What does it say? Let me show my wording is right. It's the smallest number in each particular class. So the lower class limit for the first class is 0. Second class, lower class limit is 3.5. Next class is 7, 10.5, and 14.0. So upper class limit is the highest value of the class, okay, of each class. So that would be 3.4, 6.9, 10.4. So what is considered as a class width is the subtraction between the lower class limit or the upper class limit of 2 consecutive classes. Okay, so let's just go to, I'm sorry, I hate to do this. All right, let's do this one real quick. The following table representing group of frequency distribution, number of hours spent on the computer per week for 56 students. What is the value of the lower class limits of the second class? Lower class limit of the second class. So we go to second class, which is 5.5 to 10.9. The lower class limit will be 5.5. Okay, that's what the lower class limit is. All right. So this one is a little bit different problem. Okay, well, different numbers here. All right. Still about the time spent on the computer for 55 students was a class width. So to find class width, all we're gonna do is take 2 class limits, 2 consecutive lower class limit, and find the difference. Or we can take any 2 consecutive upper class limit and then find the difference between them. So if I find the difference between the first 2 lower class limit, that's 3.5 minus 0, which is give me 3.5. So that will be my class width. So if I will subtract the first 2 consecutive upper class limit, which is 6.9 minus 3.4, all right, I should get the same thing, 3.5. So that's why my class limit is just 3.5. Okay. All right, let me go back to the definition. All right, class boundaries are number used to separate between the class. It's always minus 0.5 of each lower class limit and plus 0.5 of each upper class limits. Okay, so that's assuming minus 0.5 is assuming I'm using whole numbers. Okay, I'm using whole numbers as for each class. So here, for this particular example, okay, I'm having 1 decimal place. I'm not using whole numbers. I'm using 1 decimal place. I'm using a tenth. So for a tenth, your class boundary is minus 0.005. Okay, for all the lower class, plus 0.0, not 0.005. Okay, minus 0.05. Okay, for the lower, plus 0.05 for each upper. That's when I'm using 1 decimal place. Using whole numbers, okay, that would be just plus 0.5 or minus 0.5. Okay, I don't think none of my example here using whole numbers for class. All right, so just in case if you ever run into that problem. So that's a class boundary. Now the purpose of class boundary is to help us to connect, okay, connect each bars on the histogram. That's why histogram has no space between the bars, because the number that we put, okay, between each bar are the class boundary, okay, using the class boundary to do so. That's why histogram has no space between each bars. All right, let's come back to do this problem, okay. Following table, again, this is a computer usage per week for 54 students. What percentage of the student use a computer less than 7 hours a week? What percent? So this problem is asking for percent. As you can recall, percent is always part over the whole times 100. So less than 7 hours. So less than 7 hours, that will be, so this is 7 hours to 10 hours. So less than 7, that will be referring to 18 and 2 together. So 20 students is less than 7 hours out of the whole thing, which is 54 students times 100. So if you put this in your calculator, let me do this on the side here. 20 divided by 54, then times 100, that will be 37.03. So if I round to the nearest tenth, 37.037 something percent, if I round to the nearest tenth, the 3 will make my 0 stay the same. So my answer is about 37.0% of the students spent less than 7 hours on the computer. All right, let's do this very last one, okay? Again, percentage. Now this time I got 50 students, okay? What percentage of students use the computer between 10.5 to 13.9? So 10.5 to 13.9 is 12 students. So percent is part over the whole. So that will be 12 students out of 50. 50 because right here tell me it's 50 times 100. Round your answer to one decimal place. So 12 out of 50 in your calculator will be 0.24 times 100. That will be exactly 24%. All right. So just a quick lecture video talking about the different display for quantitative data. Okay. And also mentioning these wording called regarding to the histogram using something called the frequency distribution. All right, that will conclude this quick lecture video. Thank you for watching.